I welcome you all for today's class on projection of planes. The method of projection in which I am going to follow is change of position method. To solve the problem, the position of plane surface has to be identified. So it can be done by following these three conditions: resting position, surface inclination, line inclination. To understand the problem, I have taken an equilateral triangular lamina. So the problem goes like this: an equilateral triangular lamina of 25 mm side lies with one of its edges on HP such that the surface of the lamina is inclined to HP at 60 degree. The edge on which it rests is inclined to VP at 60 degree. Draw the projection. So to solve this, as I said, follow these three conditions. First, consider the surface inclination. In the problem, you can see the surface of the lamina is inclined to HP at 60 degree. So one has to identify that the lamina has to be placed at HP plane, and we follow the first angle of projection. In first angle of projection, the VP plane will be above XY line and HP plane will be below XY line. And now we know that the lamina has to be placed on HP plane. But how it has to be placed, whether it is corner resting or edge resting, that will be identified by first condition, that is resting position. So that will be identified here. So here you can see that the lamina of 25 mm side lies with one of its edges on HP. So make sure that the edge should be at the left side. If they have given corner resting means then the corner should become here. But in this problem they have mentioned it is edge resting. So the edge should be in the left side. So we have to represent the equilateral triangular in this way itself. Next, the naming. So one of the point I will name it as A, B and C. Next, I will project the lines upward up to the XY line to represent a view. That view we call it as front view. So the naming will be done like this. As we see from this direction, the point B is visible. So I represent it as B dash, and the point A is on the same line. That will be also be represented as A dash, but it will be in bracket because it is not seen. Next, the corner point, the C, is been represented here. So the line has been joined to get the first front view. Next, considering the same condition, that is surface inclination condition, you can see here the surface of the lamina is inclined at HP at 60 degree. So the lamina will be tilted at an angle of 60 degree, right? So with respect to HP plane, so when it is being tilted with respect to HP plane, that will be seen in VP plane. So that is why the line which is being represented here, that will be shown at an angle of 60 degree, and the naming will be same: B dash and A dash in the bracket. Next, C dash. Next, the line will be projected downwards where A dash and A will meet at some particular point that will be marked. Next, similarly, B dash and B will be meeting at some particular point that will be marked. Next, C dash and C will be meeting, that will be marked, and the points will be joined to get the second position of the top view of a equilateral lamina. Next, the final condition or final position has to be represented, that will be identified by the line inclination. You can see in the problem the edge on which it rests is inclined to VP at 60 degrees. So this is the edge which is resting, and this edge has to be tilted at an angle of 60 degree with respect to VP. So the lamina will be seen in HP plane. With respect to VP plane, if it is tilted means that lamina will be seen on HP plane. So that is why a line, the AB line, is being represented at an angle of 60 degree. Next, the same lamina, whatever the lamina is being represented in the second top view, will be placed but at an angle of 60 degree. Next, same, the lines will be projected upward: A, A dash, B, B dash, and C, C dash. The points will be marked and it will be joined to get the final position of the front view. So this is how the projection of planes of equilateral triangular lamina. Now we will learn to draw the equilateral triangular lamina in different positions. To draw that, first we have to draw a XY line of any length. Next, for naming, we have to name it as X and Y. Next, as we are doing the first angle of projection, the representation of VP will be above XY line and HP will be below XY line. Next, we will represent the equilateral triangular lamina in which it is resting with respect to sides. So, first I will draw a line of 25 mm length. Next, the exterior angle is 30 degree for a equilateral triangular lamina. So, 30 degree. Next, join it. And the triangle which we have drawn is a view. So, it should be of visible line. So, next, go for naming. So, I will name it this point as A and this point as B and this point as C. In this completes the first position of top view of a equilateral triangular lamina. Next, I will go with the projection line. Extend the line up to XY line. Similarly, from point C, extend the line up to XY line. So now we will get a view of front view of a equilateral triangular lamina in first position. So this is the length, and whatever the view we have got, that should be in visible line. So I will make it little bit darker compared to that of XY line. Next, coming to the naming part, when we see from this direction, the point B is visible, whereas point A is hidden. So I represent this point as B dash in the bracket A dash. Next, the point C is seen, so I will represent it as C dash. So this is the first representation of a view of HP top view, and in VP it is front view. Next, the surface of the lamina is inclined at HP at 60 degree, means this line has to be tilted at an angle of 60 degree here. Because I already explained that whatever the inclination with respect to HP is there, that will be seen in VP plane. So what I do, I will measure the distance. So what is the length of this line? What is the length of this line? It is 21.65. So I will draw a line of 21.65 and the angle is 60 degree with respect to XY line, and it is a view, so it should be dark line, and the naming should be same. This point, it is B dash in the bracket A dash. Next, this point will be C dash. Next, we have to get the second position of top view, right? So for that, the projection line has to be drawn. So how it will be drawn? From point B dash to B, I will take first from A dash to A, I will draw. Next, from B dash to B, I will draw. Next, from C dash to C, the intersection point will be the representation of the points. So I will join the lines, as because it is a view, it should be in darker lines. So from point C to point A, from point A to point B, from point B to point C, I will join the lines and I will name it. Whatever the naming we do in HP plane, it should be in A, B, C, D, etc. This is A, this is B, and this is C. And whatever we mention in VP plane, that will be in A dash, B dash, C dash. So we have represented the first position, second position, and finally we have to represent the third position. That will be obtained. The data will be obtained at the this condition, line inclination condition. So the line inclination condition is here. You can see here the edge on which it rests is inclined to VP at 60 degree. Means whatever the inclination is there with respect to VP, that will be seen in HP plane, right? So what I do, I will draw a line with respect to xy line, and any length, and the angle will be 60 degree. Angle will be 60 degree. Angle will be minus 60 degree. I think it has not taken minus 60. It has not taken. Minus 60 degree. Okay, so I will draw on the line. So I have to measure. By using the protractor, I will measure the angle between. So I will check, I will cross verify once again that the angle what I have given is 60 degree. Yes, it is correct. So now this view has to be placed at this particular line. Means because the edge on which it rests is inclined to VP at 60 degrees. So which is the edge that is resting? AB edge is the one which is resting with respect to VP at 60 degrees. So this edge should be represented at an angle of 60 degrees. So whatever the view it is here, that will be placed here. So for manual drawing, what I do, I will take one reference point somewhere here and I will draw the line. So that line will be of this length. So what is the length of this? As we know that the equilateral triangular lamina of having a side of 25 mm. So if this is 25, this will also be of 25 mm length. So I will draw a line of length 25 mm. Yes. Next, that should be visible. Okay, next we have to get this length and this length. So I will measure the distance. I will measure the distance between point A and C. It is 16.54. Next, similarly from here to here it is 16.54. So what I do, I will take an arc by center point. In the solid software, for manually use the compass and measure 16.54 and cut an arc. Similarly, from this point 16.54, cut an arc. So next, what we have to do, we have to join the lines. We have to join the lines from this point to the intersection point. Next, from this point to intersection point. So this is the view, and this is the arc which we have drawn. It should be of thin line. It should be of thin line. So we got a final view. So what is the view? What is the view? What is the view here? You can see here the naming is, this will become point A, this will become point B, and this will become point C. Next, final representation of front view, that is we have to go for a line and we have to draw a projection line from A to intersection of A dash. Intersection of A dash here. So that was A dash. Next, similarly, line has to be drawn from point B. Where is B dash? B dash is also on the XY line. Next, from point C to intersection of C dash. So we got the point. So now use the dark line, that is visible line, from point A dash to B dash, from B dash to C dash, from C dash to A dash. You have to join it. So now we have to mention the points. So this will become A dash, and this is B dash, and this is C dash. So this is how we have to represent a lamina which is being tilted at some particular angle with respect to some reference plane. So this is the problem which I wanted to discuss, the manually how to draw the equilateral triangle lamina. Thank you.